Okay, so we're going to look at example 1. At a certain time, a post 6 feet tall casts a 3-foot shadow. So if they don't give you a picture, you're going to have to draw one. So if this picture wasn't here, right away I would be thinking about Chris, Sadiq, stop. So I would be thinking about this side here being 6 and this side here being 3. And they're talking about the angle of elevation. They want to know what the angle of elevation of the sun is. So if the sun is up here, it's going to cause this post to cast this shadow. So we want to find this angle here. They're really asking us to find that angle of elevation. So if we look at this as our reference angle, 6 is here's the hypotenuse. 6 is an opposite side. 3 is an adjacent side. So what we have going on with this reference angle is an opposite with an adjacent with the stuff that we need to deal with. This has got to be a tangent problem. So this needs to be set up as tangent of x is equal to 6 over 3, which simplifies to 2. So tan x is 2. And if you go to the table or use a calculator, tan minus 1 in the calculator of 2 comes out to be 63 degrees. Or if you go down the table, the closest angle measure to 2 using one of our tables in one of our packets is going to be 63 degrees. So so if you're using the table to find the answer for the angle, you want to find the closest decimal that goes with 2. It might be like 1.9998 or something like that. Or it could be like 2.0011. But whatever that is, that angle that is associated with that closest decimal is going to be the answer from the table. The calculator is going to give you a little bit better decimal answer, but they're both just as good. Nemo, question?
Do you just turn the two numbers that are given to a fraction?
Depending on the pattern. Like for this one, since we have an opposite with an adjacent, we have to set up 6 over 3, and it's a tangent problem. So these numbers would get turned into 2, and then we would look up whatever angle goes with the tangent being a 2. But if it was like if you wanted to find out what this distance was, now that would turn this into maybe a sine or a cosine problem. So then you would have a different set of numbers in the fraction that you would have to deal with depending on what the pattern is. So part of this is kind of setting up the triangle, knowing where the reference angles need to go, but then also you got to pick out the right pattern. If it's a sine, you're dealing with opposite hypotenuse. Cosine, you're dealing with adjacent hypotenuse, and tangent is opposite with adjacent. So I'm gonna go through the evens. We can talk about the odds, and you're gonna be responsible for doing all of these if you want full credit. So let's just kind of talk about number 1 here. From a point 80 meters from the base of the tower. So here's the 80 meters from the base. That's this side here. The angle of elevation, which is this angle here, looking to the top of the tower, is 28 degrees. So the 28 degrees goes there, and they want to know how tall the tower is. So if you look at the pattern that we have with this one, we've got the x is the opposite side, and 80 is the adjacent side. So we have an opposite side and an adjacent side. And then here's our reference angle. Now this is the hypotenuse. So we have opposite with adjacent. With this one, this has to be set up as a tangent. So this would be tan 28 is equal to x over 80, and then you would have to solve it from there. Okay. Let's do number 2. For number 2, you've got a ladder that's 20 feet long, leaning against a building. Sadiq, try to help me. Okay, so you've got this ladder leaning up against the building. It's 20 feet long. They're telling you that it makes an angle of 75 degrees at the base of the ladder, and they're asking us how far out from the wall the base of the ladder needs to be. So the numbers that are like involved in this problem are the hypotenuse of this triangle and this side here, which is the adjacent side to this 75-degree angle. So if I was to redraw this triangle just without the building in it, I kind of did it backwards. Here's 75. The ladder they're saying is 20, and the distance out from the building is x. So with this problem, we've got an adjacent side to the angle, and we have a hypotenuse. This is the opposite side. So the opposite side, how tall the ladder reaches up the building isn't part of this problem. That would be opposite. We're dealing with adjacent, how far out from the base the ladder is. So adjacent with hypotenuse has to be a cosine problem. So this one has to be set up as cosine 28 equals the adjacent side, which is x, over the hypotenuse, which is 28. So Nemo, this kind of gets at your question, like about where the numbers go in the ratio and everything. Since this has to be a cosine, the adjacent has to go in the top of the fraction and the hypotenuse in the bottom. Now, if these were two numbers, we'd be looking for the angle, and I'd turn this into a decimal, then I'd look up the angle that goes with it in the cosine column. But for this one now, this is really the more simple version. We want to see what x is. We multiply both sides by 28. So 28 times cosine of 28 is going to be the value for x. So if I find my calculator here and multiply that out, we're doing 28 times cosine 28. So if you're using the table, you'd have to look up in the cosine column the decimal, the 4-place decimal that goes with 28, and you would do that times 28 to get the answer and round it off to 1 decimal place. The calculator's got all these tables built into it, so on the calculator we can just do 28 times cosine 28. As long as your calculator is set up, again, for degrees. So if you're using just a random TI-84 calculator in a class, go to your mode key and make sure that it's set up for degrees and not radians. Radian degrees are a different measurement system that's going to give you the wrong answer. So you want to make sure it's set up for degrees. So I'm going to do 28 times cosine 28. So 28 cos 28 comes out to be 24.7. So let's see, they want, they're not saying anything about rounding on this one. So I would put down 24.7 as my answer. And our units are, I think, feet. Yeah, we're dealing with feet. So the distance here that the ladder is out from the building is 24.7 feet. So how far from is the bottom of the ladder from the base of the building? 24.7. So that's, that's more like, that's pretty far out. And if you've done, if you've done like commercial work or, work for a company or anything like that, there's all these OSHA requirements. Like with ladders leaning against walls, there's a certain minimum angle that the ladder has to make with the wall. Otherwise, like you could lean back and the ladder could fall back with you and stuff like that. Or if you got it too far out, too much of an angle, the ladder could slide down. So, that's all kind of involved in this. Now, number 3 is one you're going to need to do. Let's talk about the angle of elevation of the sun. So we got this angle here is our angle of elevation. Now for this one, they want us to figure out how tall the building is. They're telling us the building casts an 18-meter shadow. Now 18 meters is a little bit more than 54 feet. It's like 55 feet out if you convert it into feet. They want to know how tall the building is, and our answer is going to be in meters because our units are meters for this. So if we look at the pattern here, again, here's the hypotenuse. So we've got an opposite side with an adjacent side for number 3. That has to be set up as a tangent because tangent is the one that goes with opposite over adjacent. So this one would actually be tangent of 62 is equal to the opposite, which is x, over the adjacent, which is 18. And our answer is going to be in meters. So you multiply by 18. 18 tan 62 is going to be the answer in meters. But you're going to need to complete that if you want the credit for it. Okay, let's look at number 4. A kite is flying at an angle of elevation of about 55 degrees. So if somebody's holding the kite and the string actually bows a little bit. If you've flown a kite, you'll know that. The string kind of like curves and goes up. But assuming it's a straight line, it's making a 55-degree angle. And ignoring the sag in the string, find the height of the kite if 85 meters of string is out. So we've got 85 meters of string. Now that's about 250 feet of string. It's 250 feet. Like that would be, what, like half of a block of string, I guess, something like that. And the question is, how high is the kite above the ground? If it's making a 55-degree angle and you've got like 250 feet of string. So the pattern that we get from the triangle with this is, with this being our reference angle, x is an opposite side and 85 is the hypotenuse. So in this problem, we have an opposite with hypotenuse at play, which means we have to use sine because sine goes with opposite and hypotenuse. So we would set up sine of 55 is equal to the opposite, which is x, over the hypotenuse, which is 85. And the answer then, to get x by itself, multiply both sides by 85. So 85 times the sine of 55 is going to be our x. And so if I do that, and again, our answer is going to be in meters. So they're giving us units. If they give you units, carry the units on through. Sometimes they'll try to mess with you a little bit. They'll give you meters and feet. You've got to have consistent units. So you have to turn everything to meters or everything to feet in a situation like that. Or if they give you feet and inches, turn everything to feet or turn everything into inches. So you want to have like what we call unit consistency. Nemo.
We always run with
Depending on what it says, like I didn't read the top part. A lot of times what they'll say at the top of these sheets is like round to the nearest tenth, or sometimes they'll say round to the nearest foot. I didn't look up here to see what it said. Okay, express lengths correct to the nearest integer. So thank you for asking that. So we don't really want decimals as part of the answer. So we want to round it up. So where I did number 1 or number 2 there, I had 24.7. That really should be 25 to really fit the way they want the problem answer to be. So on a multiple choice type test, 25 is going to be the answer you got to look for on this.
25?
For number 2.
Yeah, I get that.
So 25 feet is actually the real answer for number 2 to make it fit.
I think
So we want to do 85 times sine 55 to do number 4. So 85 sine 55. 85 times the sine of 55 comes out to be 69.6. So that's going to round off to 70. So 70 meters is how tall the building is. So the building's a little bit more than 210 feet tall. Now there's about 1 story per 20 feet. So it's about if you wanted to think more about it, it's about a 10 or 11 story building is what would come out to be the 270 meters. So the answer of this is x is equal to 70 meters. So x is 70 meters for this one. Okay, for number 5, we're talking about a guy wire that's holding this tower up. So the guy wire, this x actually is the hypotenuse of the triangle. And here's our 65-degree angle that the wire is making with the ground. And it's staked to the ground 35 meters out from the tower, which is about 100 feet, a little bit more than 100 feet out from the tower. And they want to know how long the wire needs to be able to reach the top of the tower. So we have an adjacent to the 65 with a hypotenuse. So this has got to be a cosine problem. So this would be cosine 65 equals adjacent, which is 35, over x. And then you would need to simplify it from there. So multiply both sides by x and divide by cosine 65. So x is going to be 35 divided by cosine 65. But this is one you guys need to finish if you want the credit for it. Okay, let's look at example 2. A person in a lighthouse 22 meters above sea level, or 32 meters, it says 22. I guess that's a 22. It looked like a 32 in the diagram, so that's a 22. So this is back, when they did this page, is back when they were making the big push to everybody using metrics for everything. So a person in a lighthouse 22 meters above sea level, that's about 70 feet above the ground, 7 stories up, sights a buoy in the water. Now their sight angle looking from the top of the tower to the buoy is 35 degrees. So that 35-degree angle of depression is the same as from the buoy, you'd be looking up at the lighthouse at 35 degrees or 25 degrees. So this is a 25-degree angle of elevation inside the triangle, but it's a 25-degree angle of depression outside the triangle. And we know how tall the lighthouse is. That gives us an opposite side to the 25. Carolyn, close your Chromebook. Second warning. Second warning for both you guys. You get to number 3, you're going to have a lunch detention. And your adjacent side is the x. How far out from the lighthouse is the buoy in the water? So we've got an opposite over adjacent. This has got to be set up as a tangent. So they set up as tan 25 is equal to the opposite, which is 22, over x, which is the adjacent. And then they solved it. They got 47.16 .799. That rounds off to 47, and our units are meters. So the buoy is about 47 meters away, like 150 feet, something like that. So again, like the pattern in the triangle points you to whether you have to use sine, cosine, or tangent. And then all of the problems are really the same. You just got sine, cosine, or tangent is the difference of which decimals you're using. But there's really two different basic types of solving the problem. You've either got x in the bottom, like with this one, where you're going to multiply by x and then divide by tan 25, or you've got x in the top, which means you just take the bottom number and multiply by the other side, and you got the answer right away. So if x is in the bottom, it's 2 steps. If x is in the top, it's 1 step. But they're all really the same. Every one of these problems is one of those two basic types. But sine, cosine, tangent depends on the pattern that the sides are in the triangle. Maddie, did you have a question? Guess not. Okay, so let's look at number 6. The angle of depression from the top of a tower to a boulder on the ground is 38 degrees. So they're telling us that this angle here is 38 degrees, which means that this angle here, in the angle of elevation from the rock looking up to the top of the tower, is got to be 38 degrees. So now we've got the angle inside the triangle. This is the triangle we're dealing with. In terms of the sides, 25 is an opposite side, how tall the tower is, and how far out is an adjacent side. So this is an opposite adjacent pattern again, which is going to be a tangent problem. So this is going to be tangent 38 is equal to the opposite, which is 25 over x. So here I'm going to multiply both sides by x. So x tan 28 or 38 is 25. Then I'm going to divide by tan 38. So x is going to be 25 divided by tangent of 38. So here's one of the patterns where you got to do the 2 steps. And sine, cosine, tangent doesn't really matter. Like the steps are the same for these. But at the end, you just have to be sure you hit the right key that matches the pattern that you're dealing with in that particular problem. So 25 divided by tangent of 38 comes out to be 31.99. So it's going to round off to be 32. And again, we're still using meters. So 32 meters is how far the boulder is from the base of the tower. So x is 32 meters, yeah.
So it doesn't matter if you use like tangent.
Depending on what you're solving for in the triangle. Like with this one, we have to use tangent because with this 38-degree angle, we have an opposite side and an adjacent side that we're dealing with, so it has to be a tangent problem. Now, if we wanted to find out how, like let's say they were going to shoot at the boulder from the tower and they want to know what this distance was, this would be a hypotenuse. Then we would do a sine problem because we'd be dealing with the opposite side with the hypotenuse. But for this one, we got opposite with adjacent, so we have to use tangent. So that's where the SOHCAHTOA stuff comes in. It's really meant to help you figure out which one of these ratios you have to use based on what you're dealing with for that particular problem. If you're dealing with the opposite and hypotenuse, you have to use sine. Adjacent hypotenuse, you have to use cosine. Opposite adjacent, you have to use tangent. If you use any of the others, it's going to be the wrong answer. To set up number 7, you got an observer on the top of the building. They're looking down at a car at a 28-degree angle of depression. So the car up to the building is going to be a 28-degree angle of elevation. So 28 jumps into the triangle down there. The car is 50 meters away from the building, and the question is, how tall is the building? So Nemo, if we look at this pattern here, here's our reference angle. What is x? Is x adjacent, opposite, or hypotenuse in this triangle? Here's the hypotenuse is this side here. So here's our 28. Once you take out the hypotenuse, a side that makes up the angle is the adjacent side. So this is adjacent. So the only other one is opposite. So x has to be opposite. So we have opposite with adjacent. Like you'll see that most of these type problems are going to be tangent problems, but every so often it may be a sine or cosine problem depending on how the numbers are given to you and what the situation is. So this has got to be a tangent because we have opposite with adjacent. So tan 28 is equal to opposite, which is x, over adjacent, which is 50. So this is the easy version. This is where you just multiply 50 times the tangent of 28, and you've got your answer. And that's it for those. Okay, so these puzzle pages, let's just do one of these, I guess. Like a telescope is mounted on a tripod 5 feet above the ground, so that's going to be important at the end. So this is number 4 on the puzzle page that has the things down the side of it. I just randomly picked number 4 because the picture looked like it was good. And they want us to figure out, okay, the telescope must be rotated 54 degrees from the horizontal. That's a tricky way of saying the angle of elevation is 54 degrees. So 54 degrees from the horizontal gives you that 54 degree angle of elevation. And what are they saying is 20 feet? It's 20 feet from the flagpole, so this distance here is 20 feet. And how tall is the flagpole? They want us to find out how tall this flagpole is. But we have to remember that we're starting up in this problem with this being 5 feet up off the ground to begin with. So we can use this triangle here, this purple edge triangle, to figure out what the value for x is, but that's not the total answer because we're going to have to add 5 onto that to get how tall the actual flagpole is totally. So this is the triangle we need to solve. We've got a 54 degree angle here. X is an opposite side. Sadiq, close your Chromebook up, please. And 20 is an adjacent side. So here we have another tangent problem. We've got opposite with adjacent and 54 degrees. So tan 54 is going to be equal to x over 20. To get x, multiply both sides by 20. 20 times the tangent of 54 is going to be x. And we're going to remember we have to add 5 onto that at the end. So if I use my calculator and do 20 times the tangent of 54, let's see what we get. 20 times tan 54 gives me 27.5. Remember, we have to add 5 onto that for the height of the flagpole. So x is 27.5. But from the original problem, we got to add this extra 5 onto it because all we found was this part right here. There's 5 more because we're starting 5 up from the ground with the telescope. So 32.5 is the answer for this one. Now, I don't know if it's rounded or not, but over here, yeah, oh, so 32.5. This one goes with catches. So let's see what the coding is on this one. Find the measure, write the word next to your answer. So number 4 goes with catches. So when you finish this, this should spell out an answer that makes sense to what you get is. So whatever this word order comes out to be, it should make sense. If it doesn't make sense, the word that seems to be out of order is probably a problem you should go back and redo because you've messed something up on it. And pretty much, that's pretty much what's going on with this sheet. And then the next sheet, kind of the same stuff. Here's a these are actually simpler triangles. So this one here, like if we look at this first one, L is an opposite with hypotenuse. So this has got to be a sine problem. And we would figure out what the angle is. If we look at M, opposite with hypotenuse, that's another sine problem. Look at D, opposite with adjacent, that's a tangent problem. Look at A, we got adjacent with hypotenuse, that's going to be a cosine problem. So this last page should give you practice on, correctly picking out the right trig function to use, either sine, cosine, or tangent based on the pattern, and you're solving for the angle. So if we did the L one, we've got an opposite over hypotenuse, that's going to be sine. We would have to set up sine of L is equal to 8 over 15. So sine L equals 8 over 15. Now what I could do with the calculator is just do sine of parentheses 8 divided by 15, or sine minus 1 of 8 divided by 15, and it's going to give me the answer. Or I could do 8 divided by 15 and get the decimal and then look it up in the table, or I could do sine minus 1 of the decimal. But with the calculator, you can do a shortcut. You really just need second sine to get sine minus 1, and whatever 8 divided by 15 is. So 8 divided by 15, it comes out to be 32.2 degrees. So angle L has to be 32.2 degrees for this one. So the second step for this was sine minus 1 of whatever 8 divided by 15 is. So I didn't have to use the decimal because I used the graphing calculator. If you have like a TI 30 or 34, you got to do 8 divided, you got to crunch the numbers, get the decimal, and then you do sine minus 1 of that decimal, and it should give you the 32.2 degrees. So L is equal to 32.2. And I guess this is rounded off to the nearest tenth. So 32 is this one. L goes in the ozone line, and sometimes there's more than one of these. I don't see another 32 anywhere. Oh, here's a 32. L goes down there in the mistletoe line. And those are all the 32s. So both of those take on L's. And then you do that for each one of these other triangles, and it should give you a definition for ozone, and it should give you a definition for mistletoe. Okay, Nemo, question?
How do we know?
If you're solving for the angle, it's going to be a -1. Like so, like this is set up as a sine problem, but because we're solving for the, now if this was an x and we knew that this was a 30, this would just be a sine problem, and we could figure out what the x was that made it work out. But if we're solving for the angle and we got the two numbers there, we got to turn those two numbers into a decimal. And since it's a sine, we got to do opposite over hypotenuse. That's what I did there. And whatever this decimal is, when we need to look up the angle that goes with that decimal, that's the -1 version. So we would have to do sine -1 to look up the angle. So if you're looking up the angle from the decimal in the table, you're kind of going backwards with the way most of these normally go, where you're looking up just a number. So that's the inverse. You're going backwards with it. So that's maybe one way of remembering that you do the -1 version. So we have to do, so we're solving for the angle that matches whatever, like 8 divided by 15 is, as a decimal, is 0.5333. So if I had one of my tables from one of the other packets, I could go down, since we're doing sine, I could go down the sine column in this table, and I'm looking for the closest thing to 0.53333. And the closest one I get is 32 degrees, which is 0.5299 in the table. So that's the closest one in the table to 5333. The next one up for 33 is 5446, and the one before it is 5150. So 32 is the closest angle to it. So without using a calculator, you still have to do 8 divided by 15. But if you don't have a sine, cosine, tangent scientific calculator, you can use the table and get the answer that way. So from the table, we get 32 degrees. From the calculator, we get 32.2 degrees. But they're rounding off to the closest degree anyway. So like all of these on this page are going to be -1 type problems. Like solving for m, for this one over here, this is another sine. This will be sine -1 of 4.7 divided by 6.4. This one's a tangent problem because you got opposite adjacent. This is going to be a tangent -1 of 34 divided by 80. This one here is a cosine problem because you have the adjacent side with the hypotenuse. This is be cosine -1 of 6 divided by 9, which is like 2/3. So whatever cosine is of 0.6667, whatever that closest angle is, that's the angle you're looking for there. Here we have angle up here now. So 25 is an opposite side, and 27 is the hypotenuse. So we've got opposite hypotenuse. This has to be sine. So this would be sine -1 of 25 divided by 27. Over here, B is over here, and the longest side, or the side opposite the right angle, is always the hypotenuse. So what we have here is opposite side and adjacent side. The adjacent side, once you ignore the hypotenuse, the adjacent side is always the side that is part of the angle. See, the hypotenuse is part of the angle too, but once you know where the hypotenuse is, which is the longest side or the side opposite the right angle, you've got to choose between opposite and adjacent. For the two that are left over, the one that makes up the angle is going to be adjacent. The one you can't touch, if you're at the angle, is going to be opposite. You're looking across at it. So this is opposite over adjacent. It's going to be tan -1 of 50 divided by 38. And whatever that is, as a decimal, you can look it up in the table, or you can just use the calculator and it's going to give you the angle measure. So all of these, I think, are that way. So these are all, I think, good practice in kind of doing that method of solving for the angle.
So all of them are sine -1.
Well, no, some are cosine -1, some are tangent -1. The pattern that they set up in the triangle tells you which one you have to use. That's where the SOHCAHTOA stuff is really important in the beginning, because you've got to recognize whether you have a sine pattern, a cosine pattern, or a tangent pattern. That's the first thing you have to recognize. And then if you're solving for the angle, it's going to be